It's pretty easy if we're asked to graph something and we're given the equation. We can put it in our calculator as long as we can get it to y equals, and we can look at the table, we can set our inequality, all that. But what happens when we are given a graph and we are asked to write the equation of the graph? Well, first of all, this is a little complicated because it's not linear. We need to recognize this as absolute value. So the question is, what are some things we know about this absolute value graph? Well, the one thing that we know for certain is the vertex. So that is our vertex, and we can actually write down the coordinate. So the coordinate looks like it's at 3, -2. Okay, so as soon as you see vertex and you're asked to write the equation of the line, you should think, the equation of the function, what form of the function do I want to write? Well, you want to write the vertex form, of course. So you need to remember what vertex form looks like. What kind of function is this? If it makes a v, it must be absolute value. So absolute value is not the only one we deal with like this. We deal with quadratics and we deal with lines. So you need to be able to tell which is which. So the vertex form of an absolute value function is, we'll just use y instead of f of x. Y is equal to a absolute value of x minus h plus k. So what did they give us? They gave us the vertex. So 3 is our h and -2 is our k. So I'm going to do this. We're going to substitute in h for h regardless. We're going to ignore this negative when we substitute it in. So we know that y is equal to a absolute value of x minus whatever h is plus whatever k is. Well, what's h? H is 3. It's positive, it's not negative. If it were negative, I would put -3 there, but it's positive. And then my value of k, which is -2. Okay, so let's go ahead and clean this up. So that gives me y is equal to a times the absolute value of x minus 3 minus 2. So the only problem is here, you're like, oh, that's all fine and dandy, but what about a? Well, what do we know about a? One, we know a is positive because our function is going up. It's not reflecting over the x-axis. So we know a is going to be positive. Well, I want to find out exactly what a is, and we'll see this later when we do quadratics. So you could kind of cheat and look for the slope of the line, but I want to teach you this right now because we will see this later on when we're dealing with quadratics. So I'm going to look for a convenient point. There's a couple of convenient points actually. There's a point here and a point here and a point here. Anywhere along here on this line. Okay, anywhere where my crosshairs intersect onto the function. So I can pick anything that's convenient. So I could pick this 0 right here, which is 1, 0. Or I could pick this y-intercept, which would be the point 0, 1. It really doesn't matter. Let's go ahead and pick this one right here. I haven't tried this, so let's see what happens. This is going to be 1, 0. We're going to pick that 0 of the function. Let's stick it in and let's see what happens when we solve for a. So we're going to substitute that in for y equals a absolute value of x minus 3, close absolute value minus 2. Okay, so that's where we're going to stick the points in for x and y. So this here is going to be our x, and this here is going to be our y. So that means my y is going to be 0 equals a absolute value. My x is going to be right here, 1 minus 3 absolute value minus 2. Remember, I'm solving for A. So let's do what's inside the absolute value because we can. So that means I'm going to copy this down. This is 0 is equal to A. Absolute value 1 minus 3 is negative 2. Okay, and then I have minus 2 on the outside. When I take the absolute value of negative 2, I get 2. And remember, that's being multiplied to the A. And I still have my minus 2 out here. I'm going to rewrite this to be 2A because that's just conventional. It looks better. Okay, so remember, I'm solving for A. So what did I do? I put in an X and Y coordinate to solve for A. So now I want to get this A by itself. So I have to add 2 to both sides of the equal sign. So I get 2 is equal to 2A. And then I want to divide both sides by 2 so I can get A by itself. And I find that A equals 1. Okay, so that's a sure way of knowing that A is 1. In fact, it is. It's the same as a parent function. Since this is a piecewise function of a line, up 1, over 1, up 1, over 1, up 1, over 1. It's just like slope. So that means I'm going to put down y is equal to 1, absolute value of x minus 3, close the absolute value, minus 2, or y is equal to the absolute value of x minus 3 minus 2. Okay, but the problem is we have an equal sign here. I have a shaded region, so it's not exactly equals. So how can I figure out if this is greater than or less than? I already know it's not equal at all because I have dashed lines. So let's do the test that we've done before. If I go to my y-axis right here, which place does y get bigger as I go up? That's my shaded region. So that means y must be bigger than the absolute value of x minus 3 minus 2. And if I wanted to actually see if this were true, if this were the right equation, I could pick a point anywhere in here. So let's just pick some point. It doesn't matter. Let's pick this one right here. So what's that point? That's a point 3, 1. So let's test 3, 1 and see if this equation is correct. So we're going to test 3, 1. So that would mean this is my y and this is my x. So is 1 greater than the absolute value of 3 minus 3, close absolute value, minus 2? So is 1 greater than the absolute value of 0, minus 2? Well, the absolute value of 0 is 0. What is 0 minus 2? The absolute value, the 0 minus 2 is negative 2. Is 1 greater than negative 2? Yes. So I know that this equation is true. The other thing you could do is put this into your graphing calculator and see if it graphs this graph that is drawn right here.